Next we are going to do NCERT optional exercise 2.4, which consists of mainly questions related with cubic polynomials. So here is one question. The question is, you have to verify that the number. So the question is 2x cube plus x square minus 5x plus 2. This is the cubic polynomial. You have to verify that the numbers given alongside. So in the question you will find there are some numbers given alongside, 1 by 2 comma 1 comma minus 2. You have to verify that these numbers which are given alongside are the zeros of this particular cubic polynomial, and also you have to verify the relationship between the zeros and the coefficients of this given polynomial. So let's see how to do it. First we need to verify that these are the zeros of the given polynomial. So what we will do is we will write f of x is equal to 2x cube plus x square minus 5x plus 2. Then we will put the values of each zeros in the place of x in this given polynomial one by one. So f of 1 by 2 is equal to 2 bracket 1 by 2 the whole cube plus 1 by 2 the whole square minus 5 bracket 1 by 2 plus 2. And then we will see by solving what is the answer. So 2 into 1 by 8 plus 1 by 4 minus 5 by 2 plus 2. Okay, so this will become 1 by 4 plus 1 by 4 minus 5 by 2 plus 2. Okay, now let's take LCM throughout and solve. The LCM will be 4. So 2 2s are 4, 1 4s are 4. So 1 plus 1 minus 10 plus 8 the whole upon 4. Now 1 plus 1 is 2, 2 plus 8 is 10, 10 minus 10 is 0 upon 4, which is 0. Therefore 1 by 2 is a 0 of f of x. Now let us verify the second 0, whether it is a 0 or not. So f of x is equal to 2x cube plus x square minus 5x plus 2. I will put in the place of x, I will put 1. So 2 into 1 cube plus 1 square minus 5 into 1 plus 2. 2 into 1 cube is 2 plus 1 minus 5 plus 2. 2 plus 1 is 3. 3 plus 2 is 5, and 5 minus 5 is 0. Therefore 1 is a 0 of f of x. Next we will verify with minus 2. So f of minus 2 is equal to 2 into minus 2 the whole cube plus minus 2 the whole square minus 5 into minus 2 plus 2. Minus 2 cube is minus 8. Minus 8 into 2 is minus 16 plus minus 2 square is 4. Minus 5 into minus 2 is plus 10 plus 2. 4 plus 10, 14 plus 2, 16. Minus 16 is 0. Therefore minus 2 is a 0 of f of x. Okay. Now we have to verify the relationship between the zeros and the coefficients of the given polynomial. So let us equate the given polynomial f of x with the standard form. So 2x cube plus x square minus 5x plus 2. You have to equate it with ax cube plus bx square plus cx plus d. This is the standard form of cubic polynomial. Please remember, ax cube plus bx square plus cx plus d. So by equating, what do you come to know? What is in place of a? 2. So a's value is 2. What is in the place of b? 1. So b's value is 1. What is in the place of c? Minus 5. And what is in the place of d? 2. Okay, so a is 2, b is 1, c is minus 5, and d is 2. Now how to verify the relationship between the zeros, which we have got here verified already, that these are the zeros. How to verify the relationship between zeros and the coefficients, that is a, b, c, d. Now we know that the three zeros are alpha 1 by 2, beta 1, and gamma. This is the sign of gamma. Okay, gamma is minus 2. Alpha, beta, and gamma. Remember that this is a cubic polynomial. Cubic polynomial's highest degree is 3, so it will have 3 zeros. Quadratic polynomial has a degree of 2, so it will have 2 zeros. So I told you in the earlier video that number of zeros is equal to the number of degree, or the highest power of the given polynomial. So first thing is the sum of the zeros. The sum of the zeros is alpha plus beta plus gamma. Alpha plus beta plus gamma is half plus 1 plus minus 2. So if you solve this, you will get 1 by 2. Okay, alpha plus beta plus gamma should be equal to minus of b by a. Now what is b? B is 1, so minus 1. What is a? Minus of minus 1, because, just a moment, let me check, it should be minus 1 by 2. The answer should be minus 1 by 2, correct. This answer is minus 1 by 2. So minus of b minus 1 by a, that is 2. Now as we can see that alpha plus beta plus gamma is equal to minus of b by a, since alpha plus beta plus gamma is equal to minus b by a, therefore verified. So first relationship is verified. Second is product of the sum of the product of the zeros taken 2 at a time. So there are 3 zeros. Now you have to find the sum of the product of the zeros taken 2 at a time. So first we will take 2 zeros and find their product. So alpha beta, then beta gamma plus alpha and gamma. Sum of the product of the zeros taken 2 at a time, and this is nothing but 1 by 2 into 1 plus 1 into minus 2 plus 1 by 2 into minus 2. If you solve this, you get minus 5 by 2. And what is what it should be equal to? It should be equal to c by a. Remember that in the first video I had given you one note in the beginning, that the relationship between zeros and the coefficients, you should have that particular note. If you don't have, just go to that video again and see first 5 minutes. I think first 5 or 7 minutes, you will find that page where the relationship between zeros and the coefficients of a cubic polynomial has been described. So the sum of the product of the zeros taken 2 at a time should be equal to c by a, and c is what? Minus 5, and a is minus 2. So minus 5 minus 2, therefore verified. And the last thing which you need to verify is product of the zeros, that is alpha beta gamma, and alpha beta gamma is half into 1 into minus 2. So if you calculate, this will give you minus 1, right? Minus 1. And what should alpha beta gamma, that is product of the zeros, be equal to? It should be equal to d by a. So d by a is what? D is 2. It should be minus of d by a. So d is 2, minus of d is minus 2, by a is 2. So minus 2 by 2 is minus 1. So product of the zeros is equal to minus d by a. Both are minus 1. Therefore that is also verified. So 3 verifications are there. In quadratic polynomials, there are just 2 verifications: sum of the zeros and product of the zeros, alpha beta and alpha plus beta. But in cubic polynomial, there are 3 verifications: sum of the zeros, sum of the product of the zeros taken 2 at a time, and product of the zeros, and they are respectively equal to minus b by a, c by a, and minus d by a. You must remember this, right? So this was one cubic polynomial. Let's look at one more example. So in this question, you have to find a cubic polynomial whose sum, the sum of the product of the zeros taken 2 at a time, and the product of its zeros are 2, minus 7, and minus 14 respectively. So we know that the sum of the zeros is 2, sum of the product of the zeros taken 2 at a time is minus 7, and product of the zeros is minus 14. You have to find the cubic polynomial, means you have to form the cubic polynomial. Now the standard form of cubic polynomial is x cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus alpha gamma into x minus alpha beta gamma is equal to 0. This is the standard form of your cubic polynomial: x cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus gamma alpha x minus alpha beta gamma. So if you know the sum of the product of the zeros, sum of the zeros and product of the zeros, you can form a cubic polynomial. Let's form it. So x cube minus, what is the sum of the zeros? 2. So 2 into x square plus, what is the sum of the product of the zeros taken 2 at a time? Minus 7. Minus 7 into x minus, what is the product of the zeros? Minus 14 is equal to 0. Let's simplify this. X cube minus 2x square minus 7x plus 14 is equal to, you don't have to write is equal to 0 because that's not an equation. So it's better that you write f of x. That is your polynomial. So your f of x is x cube minus 2x square minus 7x plus 14. So this is how you form a cubic polynomial if you know the sum of the product of the zeros and product of the zeros. If two zeros of the polynomial x raised to 4 minus 6x cube minus 26x square plus 138x minus 35 are 2 plus minus root 3, find other zeros. Now in this question, what is different? The different thing is, so this is a biquadratic polynomial. Biquadratic is a polynomial with degree 4. If you see the highest power of the polynomial, it is 4. So I told you earlier that the relationship between the degree of the polynomial and the number of zeros is that whatever the degree is, you will get the exactly same number of zeros. So if the degree is 4, if the highest degree is 4, if it is a biquadratic polynomial with degree 4, then that polynomial will have 4 zeros. Here they have given us 2 zeros already, that is 2 plus root 3 and 2 minus root 3. You have to find other zeros. Other zeros means how many more zeros you have to find? 2 more zeros. You already know 2 zeros, 2 plus root 3, 2 minus root 3. You have to find 2 more zeros, right? So for that we will first denote our polynomial as p of x is equal to x raised to 4 minus 6x cube minus 26x square plus 138x minus 35. Now you will write the value of x, which is your 0, nothing but your 0. What is your 0? 2 plus minus root 3. So x is equal to 2 plus minus root 3. So can I write this x as x minus 2 is equal to plus minus root 3, right? Now what I will do is squaring both the sides. Squaring both sides. So on squaring both the sides, what do I obtain? X minus 2 the whole square is equal to plus minus root 3 the whole square. This will become x square minus 2 into x into 2, 4x plus 4, and here you will get 3. Now you will shift 3 to the other side. I will write over here, please pay attention. So x square minus 4x plus 4 minus 3 is equal to 0. So this becomes x square minus 4x plus 1 is equal to 0. So this is a quadratic equation which you have got by solving the two zeros which you had earlier, that is 2 plus minus root 3. So definitely this is going to be a factor of our biquadratic polynomial. So what we will do is we'll do a long division where we are going to divide. So let us divide p of x by, p of x is our biquadratic polynomial, by g of x, which is equal to x square minus 4x plus 1. Now this is going to be a long division and a very long division, because here you are dividing biquadratic polynomial by a quadratic polynomial, right? So here the degree is 4, here the degree is 2. If the dividend has a degree of 4 and if the divisor has a degree of 2, can you guess what would be the degree of the quotient? Just pause the video and guess. Let's see what if your guess is correct or not. So we will do our long division and find out. Right, x raised to 4 minus 6x cube minus 26x square plus 138x minus 35, and we will divide this by x square minus 4x plus 1. So this is going to be a long division, please pay attention. X raised to 4 divided by x square is x square. X square into x square is x raised to 4. X square into minus 4x is minus 4x cube. X square into 1 is plus x square. Here there will be a negative sign, and the sign of x raised to 4 is positive, it will become negative. The sign of 4x cube is negative, it will become positive. The sign of x square is positive, which will become negative, right? So x raised to 4 minus x raised to 4 is 0. Minus 6x cube plus 4x cube is minus 2 x cube minus 2x cube minus 26x square minus x square is minus 27x square. And plus 138x will be brought down. Let us now continue with the long division. Minus 2x cube divided by x square will become minus 2x. Minus 2x multiplied by x square is minus 2x cube. Minus 2x into minus 4x is plus 8x square. Minus 2x into plus 1 is minus 2x. Subtraction, this changes into plus, minus, plus. Minus 2x cube plus 2x cube becomes 0. Minus 27x square minus 8x square becomes 35x square, but minus 138x plus 2x plus 140x. You can bring the 35 down, minus 35. Now minus 35x square will be divided by x square. So minus 35x square divided by x square is minus 35. Minus 35 into x square is minus 35x square. Minus 35 into minus 4 is plus 140x. Minus 35 into plus 1 is minus 35. Minus, plus, minus, plus. Minus 35x square plus 35x square gets cancelled, 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 and you get remainder as 0. So the final steps, that your p of x, which was the original biquadratic polynomial x raised to 4 minus 6x cube minus 26x square plus 138x minus 35. This biquadratic polynomial has been resolved into two factors. One factor was x square minus 4x plus 1. Do you remember from where did you get this? You got it from the value of the 0 which they had given in the question, which was 2 plus minus root 3. And the other factor is the quotient, which is x square minus 2x minus 35. Right? Now from this particular divisor, you already had got two zeros, or from the two zeros you had got the divisor. Which were those two zeros? 2 plus root 3 and 2 minus root 3. From 2 plus root 3 and 2 minus root 3 you got this divisor. Now from this you will get two more zeros. So how to find that? So to find that you will do splitting the middle term. So x square minus 2x minus 35. Now you will do splitting of minus 35. You will find two factors of 35 such that their sum or difference is the middle term, minus 2. So 5 sevens are. Now you want minus 2. So plus 5 minus 7. Plus 5 minus 7 is minus 2. Plus 5 multiplied by minus 7 is minus 35. So which gives x square plus 5x minus 7x minus 35. Just draw underlines and take out common x. X plus 5 minus 7 comes out common. X plus 5. X plus 5 is common, and x minus 7. So these are the two factors of your quotient. Now you will equate these two factors with 0. Therefore x plus 5 is equal to 0 or x minus 7 is equal to 0. Therefore x is equal to minus 5 or x is equal to 7. So these are the two zeros, and therefore the remaining zeros of p of x are minus 5 and 7. Minus 5 and 7, right? So that's your complete question. You have divided the polynomial, you have factorized the given polynomial completely, and also you have found the two remaining zeros. You have done long division and everything. So have a look at this video properly and you will understand this concept. This chapter is over, and I'm just going to take doubts now. Mostly I've done all the types of questions, even the challenging ones, difficult ones, cubic polynomial types, which is mostly not part of your syllabus as per the last year's revised syllabus, but still I have done that because we should have the knowledge. Whether or not we will use it, that is secondary, but we should have all the knowledge which is given in the textbook. So full NCERT plus some of the exemplars are done. Now complete the remaining exercises and we can move on to the next chapter. See you in the next video. Bye.